So in today's video, we are going to go over questions from IB Maths AASL exams of the year 2022 and 2021. So the first question is from year 2022, November, paper 1, Maths IB Maths AASL exam. So it says consider a circle with a diameter AB where A has coordinates of the 1, 4, 0 and B has coordinates -3, 2, -4, and we need to find the coordinates of the center of the circle. So we are going to construct a diagram first. So we have a circle like this, and we have a point A and point B, and these 2 points create as a diameter, okay, and point A has the coordinate of the 1, 4, 0. Point B has a coordinate of -3, 2 and -4. Question A, we need to find the coordinates of the center of the circle. So we need to find the center. So we need to find this coordinate x, y, and z. Okay, so since we know that the center of the circle is the midpoint of the diameter AB, the midpoint of the diameter AB, we are going to use the midpoint formula, which is m equals x1 plus x2 divided by 2, y1 plus y2 divided by 2, z1 plus z2 divided by 2. This is in your formula booklet, right? So we can say 1 plus -3 divided by 2, 4 plus 2 divided by 2, 0 plus -4 divided by 2. Then we get -1, 3, -2, and this is the center of the circle. Question B, we need to find the radius of the circle. So actually this is the question A, I. So this is second part of the question A. So we need to find the radius of the circle. So we know diameter AB's coordinates, right? Point A and B. So what we need to do is we first have to calculate the diameter of AB, the length of the diameter of the AB, and we need to divide that by 2 to calculate the radius of the circle. Or we can calculate the distance from the center to the either point B or point A, right? Then we can also calculate the radius, okay? Because we just calculate the center, which is the midpoint of the diameter AB. So we can just calculate the distance between the center and point B, and this is equal to radius of this circle. Then we can say the center is -1, 3, and -2, and point B has coordinate of -3, 2, -4, and using this information is using the distance formula, where we need to do x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared and the square root to calculate the distance. So we have to do -3 minus 1 square plus 2 minus 3 square plus -4 minus minus 2 square. Then we get the distance of the square root 9. Then we get it equal to 3. Okay, then let's continue from the question number A. So now the circle forms the base of the right cone, whose vertex V has coordinates of -1, -1, 0. So the point B, vertex, has the coordinates of the -1, -1, 0. Okay, so now we need to find the exact volume of the cone. Okay, we know that the center of the base, which is the midpoint of the line AB, has the coordinates of the -1, 3, -2, which is the center of the circle, which is the base, right? So to find the exact volume of the cone, we need to use the volume of the cone formula from your formula booklet, which is 1/3 times pi r square, which is the base, times the height. Okay, you can find this formula from your formula booklet. Okay, so we first have to calculate the height. This is the only information that we are missing. So the height is between the vertex and the center. Okay, so what you're going to do is we're going to again use the distance formula to calculate the distance between the vertex and the center. So height is equal to the distance between the V and the center. So it is equal to -1 minus -1 square plus 3 minus -1 square plus -2 minus 0 square. So we get square root 20. Okay. Then using this information, we can calculate the volume of the cone. So V volume of the cone is equal to 1/3 times pi r squared. The r value we calculated from the question AII. So 3 square times the height that we just calculated, square root 20. So the answer is 3 pi times square root 20. Or you can leave it as 6 pi square root 5. So let's do second question of the day. So this question is from year 2022, November, IB Maths AA, SL, paper 1. So it says that let A be a constant where A is greater than 1, and we need to show that the left hand side is equal to the right hand side. Okay, so we first going to start with the left hand side. I mean, left hand side is more complicated, so it's better to simplify the left hand side and make it equal to the right hand side, right? So we're going to go A square plus this equal to right hand side, and we're going to expand that fraction part. So we get this. Then we can say the A squared plus a to the power of 4 minus 2a squared plus 1 over 4. Then we're going to add these two terms together by multiplying the 4 over 4 to the first term. Then we get 4a squared plus a to the power of 4 minus 2a squared plus 1 over 4, right? Then we can simplify this further into a to the power of 4 plus 2a squared plus 1 over 4 equals, then we can simplify this part into the a squared plus 1 over 2 to to power 2, which is equal to the right hand side. So we have shown that the left hand side is equal to the right hand side. Then let's do the second part of this question. So we need to consider a right angle triangle with the side of the length a squared minus 1 over 2 and a squared plus 1 over 2. So this is the right angled triangle. So we know that the triangle has a shape like this, and it has a 90-degree angle here. Okay, we need to find the expression for the area of the triangle in terms of the a. Okay, so we have a side a squared minus 1 over 2 and a squared plus 1 over 2. So the first step is which side is what, right? But from the question A, we know that the a squared plus a squared minus 1 over 2 squared is equal to a squared plus 1 over 2. Okay, this is something we already proved from the question A. Then from this statement, we know that when we apply this statement into this right triangle, we know that this is very similar to a squared plus b squared equals c squared, which is the Pythagorean theorem. Okay, so we can say the a is one of your leg, and the b is a squared minus 1 over 2, and a squared plus 1 over 2 is your hypotenuse. Okay, then we need to find the expression for the area of the triangle in terms of the a. So we know that the area of the right triangle is same as 1 over 2 times base times height. So we can say 1 over 2 times a times a squared minus 1 over 2. Okay, and this is same as a times a squared minus 1 over 4, which is same as the a cubed minus a over 4. But I should say you can stop at this point because this is the simplest form of the answer. Okay, so the third question that we're going to try today is from year 2022, November, paper 2, IB Math AASL exam, and it's timed on 0, question number 2. So the following diagram shows triangle ABC with the side AC equals 24 and side BC equals 17, and the angle ABC, the angle of the point B is 113 degree. So question A, we need to find the angle BAC, so means we need to find the angle here. So we need to find this angle. Okay, so you can see that from this missing angle, we know the side, the corresponding side, or the opposite side from this angle, right? And we know the angle 113 degree, and we know its opposite side. So means we know two sides and one angle, and we need to find the missing angle, right? So we know the so we know the two sides and one angle, so we need to find this missing angle, right? So means we can use a over sine A equals to B over sine B rule, which is the sine rule, right? Then we can do 24 over its corresponding angle equals to the side and its corresponding angle, but the missing angle, right? This angle A. So we can do sine. Let's rewrite this part as a sine B angle AC. So we need to find this missing angle. Then using the calculator, we know that sine BAC is equal to approximately 0.6504. The key is using all the numbers, right? Then we can do the inverse sine. Then we get angle BAC equals to, so we need to do inverse sine. And make sure you use all the numbers from the previous calculation. Then we get about 40.6943. And since we need to leave our answers in specific, our answer is approximately equals to 40.7 degree. Okay, then let's do the question B. We need to find the AB. So AB is the side here. So we need to find this side. Okay. We just calculated, so let's redraw this triangle here. So this is the triangle that we have, and we know that this is point A, point B, and point C. We know that this angle is 113 degree. This side is 17, 24, and we also calculated this side as 40.6943. Make sure you use the number before changing it to the specifics, right? And that means we can also calculate this angle using the 180 rules, right? So we can do this, and we get that angle C is 26.3056, and we need to find that missing side, right? That means we know that all three angles and then two sides. That means we just missing one side, right? In that case, we can use the cosine rule. So we can do c squared equals a squared plus b squared minus 2ab times cosine c. Then we get c squared equals to 17 squared plus 24 squared minus 2 times 17 times 24 times cosine. Make sure you use all the digits, right? So it's 26.3056. So the C value, which is equals to AB, so we can replace the C with the AB, right? So AB squared is equals to 133.502. Then we can square root both sides. Then we get AB equals to square root 133.502, and is equals to 11.5543 using your calculator. Then it is approximately equals to 11.6, and that's your answer. Okay, so this question is from year 2022, May paper 2, IB Math AA SL exam, and this is time zone 1, question number 7. So again, paper 2 means GDC, right? This you can use GDC. And let's do this question. So we have a solid metal ornament that is in the shape of the right pyramid with the vertex V, square base A, B, C, D. The center of the base is X. The center of the base is X, and point V, which is the vertex, has coordinates of 1, 5, 0, and point A has coordinates of the negative 1, 1, 6. So we need to find the length of the AB. So AB is here, okay? So using the distance formula, since we know the coordinates of this point A and point V, we can just simply use the distance formula to calculate the length between point A and point V, okay? So distance formula from your formula booklet is as follow. Right? Then since we know that point A is negative 1, 1, 6, V is 1,505,0. We can substitute all these numbers here. So I'm setting this as x2, y2, and z2. And the point A as the x1, y1, and z1. So we can do 1 minus 1 square plus 5 minus 1 square plus 0 minus 6 square. Okay. Once you do this, you get about 7.48331, right? And then since you need to write your answers in specific, you get 7.48 centimeters. Okay. Or you can also leave it in the square root form, which is square root 56, or 2 square root 14. Okay. However, since you always have to write your answer in the simplest form, if you're writing in the square root form, you should write your answer in this format, or you should just use GDC to calculate the number without the radicals. Okay. Question B, given that the angle ABV is equal to 40 degrees, we need to find the line AB. Okay, so let's look at the diagram. Okay, so we know that angle A, V, and B, which is this angle here, is 40 degrees, right? It's just one side. So it's just referring to this triangle or this side only, right? Then let's redraw this triangle. Okay, so we can say, okay, so this is the triangle, and we know that this is point A, point V, and point B, and the angle here is 40 degrees, and we just calculated that this side AV has the length of the 7.48331. Okay, and then we need to find this length here. Okay, so this is you can see that this is a square based right pyramid, right? That means this is a equatorial triangle. Okay, the four side that we have is the actually equilateral triangle. Okay, so you can say that this side, the side VB, also has a length of the 7.48331. Okay, that means we also know the two angles here too. However, this is not necessary to calculate, right? Because since we know the angle, and then we are just trying to find the corresponding side or the opposite side from that angle, and we also know that the two neighboring sides, we can just use the cosine rule to calculate this missing part, right? So we can do the AB square is equal to AV square plus BV square minus 2AV times BV cosine angle AVB. Okay, then substituting the numbers, corresponding numbers, will give us something like this. Right? Then we can say that AB is same as square rooting all this. I'm just going to say like square rooting all this, right? Then the side AB is equal to 5.11888. Then since we need to write our answers in specific, this is approximately equal to 5.12 centimeter. Okay, then let's continue with the question D. So we have another information. So a second ornament is in the shape of the cuboid with a rectangular base of length 2x, width x, and height y, and the cuboid has the same volume as the pyramid. And then cuboid has the minimum surface of this variable. We need to find the value of the s. Okay, so this question is a optimization question. You can calculate this question using calculus or GDC, the graph function. Okay, for this question, I'm going to use the GDC, the graph function, or the graph function in GDC to calculate the answer, because it does not ask us to use the calculus. Okay, so we have a cuboid, means it's the shape that has shape like this. Okay, and we know that one side has the 2x as its length, another side with the x, another side with the y. Okay, to use the optimization with this question, we need to set the two equations because we have two unknown variables. Okay, so we know that the volume of this cuboid is x times 2x times y, and is equal to 57.2 from the previous question. Okay, and then since we need to calculate the surface area, we can set another equation with the surface area, another the side, or the side that's neighboring, that has a the width x and the height y. We know that its area is x times y. Okay, and then the top side that has the length and width, it has area of the 2x times x, and then this actual green side is 2x times y, right? So it's 2xy here. So we know that there is a side that has the area of the 2xy and xy and 2x squared. Okay, so we have to add all of this to find the area. However, there's a 2 of each, so we're going to do multiply 2 to the whole thing to find the total surface area. Okay, then since we need to get rid of one of the variables, I'm going to set this volume as I'm going to simplify first, so it's going to be 2x squared times y equals 57.2. Then this is, I can rearrange this equation into y equals 57.2 over 2x squared. Then we can substitute this into this equation here. Let's simplify this first, so it becomes 2x squared plus 3xy, right? Then 2 times 2x squared plus 3x times 57.2 over 2x squared. Then this is equals to, or gets simplified into 4x squared plus the x gets simplified here, and then some of the numbers get simplified. Then we get 3 times 57.2 over x. Okay, once you got this equation, we know that s is equal to this, right? So you can put this into your GDC, the graph tab. Okay, you can set s as y and plug in 4x squared plus 3, 57.2 over x. Then you need to find the y value of your minimum point. Then you get your s value equals to 92.6401, so it's approximately equals to 92.6. Okay, so let's continue with this question. So new information is given. The volume of the pyramid is 57.2 centimeter cube, and we need to find the height of the pyramid, right? So new information is volume, and then we know that to calculate the volume of the pyramid, we have to use the formula 1/3 times base times height, right? And since we need to calculate the height, and also we know the area of the base, right? So area of this pyramid, base of this pyramid is square, right? Because we have a right pyramid. Then from question B, we know that the square of this pyramid looks like this and has the side AB and BC and then AD and DC, right? And from question B, we have calculated the side AB as 5.11888. That means since this is a square base, the side BC also has the same length, 5.11888. That means using this information, we can say the volume of the pyramid is equal to 1/3 times 5.11888 times 5.11888 times height is equal to 57.2. Then solving for the height can give us the value of the height, right? So we can say 1/3 times 5.11888 squared, because there's two of them, will give us the value 6.54886. And since we need to identify our final answer in specific, we can say that the height Bx is same as 6.55. Okay, so so the next question that we're going to try is from the specimen papers. So this is specimen paper 2, IB Maths AA essay exam, time zone 0, question 7. So we have Adam here sets out for the hike from his camp at point A, and he hikes at an average speed of 4.2 km per hour for 45 minutes on a bearing of 35 degrees from the camp until he stops for a break at point B. Okay, so question A, we need to find the distance from point A to the point B. So we have a diagram here. So he walks from the point A to point 5 with the speed of 4.2 km per hour for 45 minutes. Okay, and we need to find the distance between the point A and point B using this information. So the distance formula is speed times time. Okay, this is the only formula, like from physics, you can say that you need to know. It's not really only formula, but this is the formula that you need to know from physics for this IB mathematics course. It is identified in its curriculum. So to find the distance, what you need to do is you have to multiply the speed 4.2 km per hour with the time 45 minutes. However, you can see that the unit between the speed and the time is different, right? So we need to convert that time to hour by multiplying every 1 hour has a 60 minute, the conversion factor, right? So this is your conversion factor. So when you do this, you get AB, the distance, equals to 3.15 kilometer. Okay. Then we know that Adam leaves point B on a bearing of the 114 degree and continues to hike for a distance of 4.6 kilometer until he reaches the point A. Okay, so this is the bearing. It's happening here, right? And then heat hikes about 4.6 kilometer. Okay, then let's do the next question. So question B, we need to show that the angle ABC, the angle B is 101 degree. Okay, so we know that from the previous question, this is our diagram. Okay, that angle here, the bearing is 114 degree, and then the distance between the point B and point C is 4.6 kilometer, and we need to show that the angle ABC here is 101 degree. Okay, so what you can do is you can use the parallel rulers here. Okay, so it means you can draw two lines that passes through the point A and point B like this. Okay, that means when you look at these two lines, you can see that there's a line angle is happening between two parallel lines, right? That means when angle here is 35 degree, your angle here is also 35 degree. Okay, and or since you know that the angle here is 114 degree, and we actually has a parallel line, right, or the straight line here in this case, then means the angle on straight line is 180 degree. So means the angle right here, 180 minus 114 is equal to 66 degree. That means when we add these two angles, 35 degree and 66 degree, 101 degree. So we have shown that the angle ABC is 101 degree. Then let's do II. We need to find the distance from the camp to the point C. So we are trying to find the distance between the point A to point C, and we also know that this angle is 101 degree, and we know that the distance between point B and point C is 4.6 kilometer, and we also know that point A to point B is 3.15 kilometer from the question A. That means we know the two sides and one neighboring angle, means we need to use the cosine rule. Okay, so we're going to do AC squared equals to 3.15 squared plus 4.6 squared minus 2 times 3.15 times 4.6 times cosine 101. Then the AC, value AC is we can just square root everything, right? Then we get AC value equals to 6.0507. So approximately the line is equal to 6.05 kilometer. Then we need to find the angle BCA, means you need to find this angle. Okay, since we know that the side AC is about 6.0507, we know that this angle is 101 degree. That means we know the corresponding side from that angle C, and we know the side and angle that are corresponding to each other, which is these two. That means we can use the sine rule, right? So we're going to use the sine rule. So we're going to do 3.15 over angle BCA, sine BCA, right, equal to 6.0507 over sine 101. Again, you need to use the every single digit, right? You cannot use the number that's been rounded up or rounded down, right? Then we can say sine BCA is same as 3.15 times sine 101 over 6.0507. Then the angle BCA is equal to inverse sine, right? And everything. And this is equals to 3.732862. So it is approximately equal to 30.7 degree. Okay, so let's continue with the next question. So we have Adam's friend Jacob wants to hike directly from the camp to meet Adam at point C, and we need to find the bearing that Jacob must take to point C, right? So you know that the point A is where the camp is, and from the previous question, we know that there's a line between AC line to go directly from the camp to the point C. We need to follow this green line, right? So according to the question, what we need to do is we need to find the bearing from this true north line to this green line here. Okay, means we need to find this angle to find this total true line, total angle, okay, from the true north line. Okay, so we know that this is 35, we know that this is 101, okay, and also we know that this angle is 30.7328 from point C. Then we can calculate this red part, or the angle that is colored in red, right? So to calculate that angle colored in red, we have to do 180 minus 101 minus 30.7328. Then we get 48.268. That means the angle that Jacob needs to take from this true north line to go from the camp to meet Adam at point C is equal to 35 degree plus 48.268. So it is 83.268. So the bearing is 83.3 degree. Then the last question. So the Jacob hikes at an average speed of the 3.9 kilometers per hour. We need to find the nearest minute, the time it takes for Jacob to reach point C. Okay. So we need to find the time. So we're going to use the distance equals speed times time formula. However, we have to rearrange this formula into time equals to distance over speed. Okay, and also from the question B, we know that the distance from A to C is equal to 6.0507. That means the time that the Jacob needs to take is 6.0507 over speed, 3.9 kilometers per hour. However, since we need to find in terms of minute, what we can do is we can first calculate this into 1.55146 hour. After that, we can convert this to minute using the conversion factor. Every hour there's a 60 minutes. Then we can do 93.087 minutes as our answer. However, since we need to find it to the nearest minute, we have to say it is approximately 93 minutes.